All right, welcome to video 4. I asked you to take a quick look at the three graphs on page 61. I've replicated them here. Three different functions. The first one, f of x equals x squared minus 1 divided by x minus 1. This is a linear function with a hole at x equals 1. The limit as x approaches 1 is 2 because you think you're going to be at 2, even though there's a hole there. Remember from my introductory video, I had the little bugs and they were crawling along. Where did they think they were going to get to as they crawled closer and closer and closer to x equals 1? They think they're going to be there. They're not, but it doesn't matter because it's a limit. The second is a piecewise function, which you may or may not have seen. A piecewise function is defined differently for different values of x. This is the linear function with a hole for every value of x except x equals 1. This piecewise function says that when x is equal to 1, then the function is equal to 1, which means there's a dot right down here. Still a function because only one y value for every x value. Notice that the limit as x approaches 1 is still 2. My bugs still think they're going to be right there at 2, even though they wouldn't. They're going to be down here, but they think they're going to be up there at x or at y equals 2. Finally, an actual straight up linear function, h of x equals x plus 1. The limit as x approaches 1 is still equal to 2. Just notice that it doesn't matter what the actual value of the function is at x equals 1. We don't care. When we're dealing with a limit, what we're saying is what happens as I approach that from either the left or the right. Okay? So what do we need to do next? Also on page 61, some quick properties of limits. Guys, these are pretty straightforward. I think that the best way to do this is for you to look at the properties, and then we will do some examples. You have a sum rule. What happens if you add two limits? You have a difference rule. What happens if you subtract two limits? You have a product rule, a quotient rule, and a constant multiple rule. These are basically just like regular old math, where you've got what happens when you add two numbers, subtract two numbers, divide two numbers. So take a look at those. I'm going to pause the video for just a second. I can't. Why can't I pause the video? I don't know. This one's not allowing me to pause, so that's weird. Maybe I'm not even recording. I'm just wasting my time. I think I'm recording. All right. Example 3. Using properties of limits. We have a limit. This, by the way, is on page 62. We have a limit as x goes to c of some function k, and that limit is equal to k. We have another limit as x goes to c of some function. You know, they say x. I'm not sure that I like this. Okay, well, we'll just use it. And that's equal to some value c. Okay, so let's use one of the rules. The limit as x goes to c of x cubed plus 4x squared minus 3. Well, this can just be written as the limit as x goes to c of x cubed plus 4 times the limit as x goes to c of x squared minus the limit as x goes to c of 3. Well, that's c cubed plus 4c squared minus 3. Pretty straightforward. Guys, there's one more example over on page 62. Why don't you take a look at that example and then do exercises